Okay, so let's do a ladder problem. And I've already sketched the picture in here. I've got a uniform ladder 10 meters long with a mass of 20 kilograms, leans at an angle of 60 degrees from the floor against a frictionless wall, and a 65 kilogram painter climbs the ladder. So first of all, we want to find all the forces on the ladder from the wall and the floor. And then secondly, we want to know how high can the painter climb the ladder before it's going to start to slip if the coefficient of static friction between the ladder and the floor is 0.4. Okay, so let's first draw on all our forces. So what forces do we have? We're going to have the ladder has a weight, which is its mass times g downwards. The painter has a weight, which is his mass times g downwards. Okay, so I've got the weight of the ladder. I've got the weight of the painter. Right, what other forces do I have? Well, we know that if the floor weren't there, the ladder would fall through the floor. So we better put a normal force upwards from the floor. And similarly with the wall, if the wall weren't there, the ladder would fall through the wall. So I'm going to have a horizontal force from the wall. What else will I have? Well, we've got a clue in part B. We've got to have friction with the floor, otherwise the ladder is going to slip downwards. And we're told that there's no friction on the wall, so there's no force, no vertical force from the wall. So I've got 3 forces that I don't know and 2 forces that I do know. So I need to find the normal force, the force of friction, and the horizontal force. The weight of the ladder and the weight of the painter I can figure out. So the weight of the ladder is 20 kilograms times 9.8, which is 196 newtons. The weight of the painter is 65, that's his mass, times 9.8. Okay, and 65 times 9.8, just a second, I don't have that calculated out separately. 65 times 9.8 is 637 newtons. Okay, so now what's the next step? Next step is to take the sum of the vertical forces, set it equal to 0, and the sum of the horizontal forces, set it up to 0. And the nice thing about ladder problems is that all of the forces are all either straight up and down or straight across. So we don't have to break anything into components. All right, so I've got the force of friction to the right, and I've got the horizontal force to the left, and that's the only horizontal forces I have, and that's equal to 0. So that means that the force from the wall and the force from the floor are just equal and opposite. So if I find one of them, I know the other one. All right, how about vertically? Well, vertically, I've got the normal force up, and I've got the weight of the painter and the weight of the ladder down equals 0. So that tells me the normal force, put a little line there, I went a bit too close, is 196 plus 637. So I've actually got my normal force. So my normal force is 833 newtons. Okay, so do I know any of my other forces? Do I know the force of friction? Do I know the horizontal force? Well, I know from module 4 that the force of friction is mu times the normal force when I'm at the maximum value. And I'm told that I'm right at the point where the painter is going to start slipping, so I know that I'm at Fs max. So it's going to be 0.4 times 637, times 833. So 0.4 times 833, which is 333.2 newtons, and that's also equal to Fh. So I have now found all my forces just using the 2 force equations. So do I need to use the torque equation? Well, yes, I do, because the one thing I don't know is I don't know how far up the ladder the painter is. And that's what I got to find in part B. So I'm going to have to use the torque equations to find the position of the painter. And so I'm going to put my axis always where I have the most forces. So the most forces that I don't know, well, I know all the forces, but the most forces are down at the floor. I've got 2. So if I put my axis at the floor, then the torque from the normal force and the torque from friction are both going to be 0, so I'm only going to be left to calculate 3 torques. So I've got the torque from the painter, the torque from the ladder, and the torque from the horizontal force of the wall. Okay, so what are all those equal to? Well, they're equal to the size of the force. I know the size of the force, so for the painter it's 637. For the ladder it's 196. And for the horizontal force it's 333.2. And then I need to put in the R. And what's R? R is how far up the ladder are they. So the painter is X up the ladder. We don't know what that is. We're trying to find it. The ladder, that force acts at half the distance of the ladder, so that's going to be at 5 meters. And the horizontal force acts right at the end of the ladder, so that's going to be at 10 meters. Then I need to figure out the torque. Remember, torque is FR sine theta. So I need to figure out what is the angle for each of these. And that's where the difficult part comes in for ladder problems, is figuring out the angles. So let me draw a little picture here down. I'll go over on this right hand side. So I've got the ladder is at 60 degrees to the floor, and I've got 2 forces that are acting straight down, the weight of the painter and the weight of the ladder. And I've got 1 force that's acting back horizontally. And what do I need to find the angle with? I need to find the angle that those are from the ladder, which is my diagonal line there. All right, so the horizontal force, that one's easy, because if you look, that angle there is 60 degrees, because those 2 angles are symmetrical. So that's going to be sine of 60. Or you can do sine of 120 if you want to. 180 minus 60, you'll get the same thing. But what's the angle between the red diagonal line and that vertical line that's the force? Well, if I draw a triangle, this is 60 degrees, that's a right angle triangle. So the unknown angle that I have in there, 60 plus that angle have to add up to be 90, because remember the sum of the angles in a triangle is 180. So that's going to be 30 degrees. So if I put all my angles in, I can get my numbers. So I'm going to get 98. Oops, sorry, put my number in the wrong spot. This one is 98. Sorry, I have my numbers on a sheet of paper, but that doesn't look right at all. Let me do a calculation. So 196 times 5 times sine of 30, which is 0.5. That should be 490. So this is 490 Newton meters. All right, then I've got 637 divided by 2. So I've got 318.5 x Newton meters. Remember, we don't know what x is. And then I've got 332.2 times 10 times sine of 60. And I'm not trusting any of my numbers now. I'm going to recalculate. I get 2876.9 Newton meters. Okay, so those have to add up to be 0. So that means some of them have to be positive, some of them have to be negative. So to get the direction, I'm going to take my pencil, I'm going to put it along the paper in the direction of the ladder, hold it at the bottom where I say my axis is. Now if I pull down like the weights, it's going to rotate clockwise. So I'm going to make those 2 guys negative. And if I pull over towards the left at the top, that's going to make it rotate counterclockwise, so that's going to be positive. So my sum of my torques equals 0. I've got minus 318.5x minus 490 plus 2876.9 equals 0. So that means that x is equal to 2876.9 minus 490 over 318.5, doing the algebra. So let me just go ahead and put in my numbers. I get x is 7.49, and the units will be meters. Okay, so the painter can actually climb 3/4 of the way up the ladder, so he's actually, my drawing, it's drawn incorrectly, he's actually up above the center of the ladder before it starts to slip. So make sure that you can do both painter on ladder kind of problems and sign hanging from the wall kind of problems for the exam.